All right, hi everyone. So we are starting our semester review, and today we're going to look at chapter 7, which was our similarity, so ratios and proportions, similar figures. And then we're also going to look at chapter 8, which was our right triangle unit. So let's go ahead and take a look at chapter 7 to review here just a little bit. All right, so first thing, a ratio, to remind everybody, is a comparison of two quantities, and we could write that in 3 ways. We have the first quantity with the word to and the second quantity, the first quantity with colon, and then the second quantity, and then the first quantity over the second quantity. So essentially using division. And we use the division a lot when we're creating what's called a proportion, when we compare two quantities to possibly find a missing piece. So that's a comparison of two ratios gives us a proportion. So let's take a look at our first proportion here, and we're going to solve this one. So to solve out our proportions, we must cross multiply, find those cross products. So x times 14, that is 14x. And then we do the same thing the other direction for 7 times 9. All right, so 14x is the same as 63. And so now we can divide out that 14. And my x is equal to 4.5. Or we could also have 9 over 2. Either of those are acceptable and would be considered the right answer. Let's check out number 2. Same idea with the cross multiplying. So now we're looking at 4 times that expression. So 4 times x plus 9 is equal to, now we go the other direction, 3 times 2x minus 3. And this is where your distribution will come in. So we're going to take the 4 times x, so 4x, 4 times 9, so that's a positive 36, equals, same thing to the other side, 3 times 2x, 6x, 3 times negative 3 is a minus 9. And now we can keep going with our solves. So I always start with the smaller letter first, which is our 4x. So I'm going to subtract it away. So 36 is equal to 2x minus 9. Now we can add the 9 back. So 45 is equal to 2x. Divide out that 2. And my x is equal to, again, we can leave it simplified as 45 over 2, or we could have 22.5. Either of those, again, would be the correct answer. All right, some of the other things we looked at with similarity and ratios were similar polygons, whether it was a triangle, a square, a quadrilateral, whatever the case may be. So it was all about matching up the sides, and these are where our markings are going to come in. So if I've got one curve with one curve, and V has 2 and B has 2, then 12 has to match with 16 because it's connecting to matching pieces. So I'm going to use that to make my first proportion. So this is created by going left to right. And now we do the same thing to our other piece. The x matches with the 22. So equals x over 22. And now we will solve this out. So 16 times x, 16x, 12 times 22 264. Now we can divide out both sides by that 16. And my missing x is equal to 16 and a half, 16.5. And there is our final. Now, some of the other things that we had with our proportional pieces here were the parallel lines that we saw, whether they were in triangles or not. And this could be broken down into different pieces. So I'm going to just stick some labels in here. And this little section D. So we saw a couple of ways that we could set this up. We could have A over C is the same as B over D. So this one was set up as left over right. Or because of the parallel, we could have A over B is equal to C over D. And in this case, we were looking at top over the bottom. Either of these setups are going to give you the right answer. So again, A was that piece of the triangle, B was that little section, C was the space from P to T, and D was that little piece. Either of these, again, are correct. Now, our mid segment is always half of the parallel side. So this segment, let's give it a name here. Let's call it A. And let's say this whole piece here was our B. So A is supposed to be half of B. And again, A is this part. The other way you can see this is B is equal to 2 times whatever A is. And we could use that to solve of our missing piece. Now keep in mind, because these are mid segments, those sides of the triangle are being cut in half. So we also want to watch for that, because we could have pieces there as well. All right, now we also have our parallel lines, kind of looking at these in either direction when they are not in the triangle, but we can set them up the same way so that as we did when they were. So we can again solve these in two ways. We can go A over C is equal to B over D. Oops. There we go. And again, this was using left over right. Or we could do top over bottom. So A over B will equal to C over D. Again, either of these setups are going to give you the right answer. Now, when we look at those parallel lines, when they become equally spaced apart like we have here, remember, when you have one set of lines that are equal, you automatically get the other side as well. All right. So let's keep moving along, just reviewing our notes, and let's look at some other ways that we wrote proportions. We also had proportions with our special segments in triangles, like the altitudes. So remember, for altitudes, our formula said that we can do altitude. Whoops, I'm going to have to move that. Altitude over altitude. So in this case, AD and FJ is equal to side over side. Or we could say altitude over altitude is equal to side part, in case they only give you DC or DB, or maybe JH or JG. Now, we also had medians. So similar to the last one, median over median. Was equal to side over side. So again, our medians are the yellow, the line that's inside your triangle. And then we could also have, like the one before, median over median could equal the side part over the side part. Just make sure when they're giving you those parts of the side that if one triangle gives you the left part, make sure you use the left part from the other triangle. The last one that we looked at with our special segments was the angle bisector. And we could see this one in two ways. One way was like what we saw before. Angle bisector over angle bisector is equal to side over side. But when it comes to another piece, if we're dealing with an altitude in one triangle, I'm sorry, not an altitude, an angle bisector in one triangle, it's all about the parts. So we could have matching legs here. So let's label it like we were kind of doing with the other one. I'm going to call this piece A. I'll call this piece B. And then let's say we have C and D. So A is this whole piece, the long top there. B is that short little piece. Notice it's on the same side though. C is that long piece on the bottom, and D is that short piece. And again, the line in the middle is our angle bisector. And so the formula says we can do A over B is equal to C over D. That could be flipped over if needed. Or we could do A over C which is equal to B over D. Either of those are going to give you the correct answer. So let's try just some practice questions real quick using those last pieces. So again, we can solve number 4 here. It's the parallel lines in a triangle in 2 ways. I'm just going to go with 4 over x because they're on the same side, and 5 over 12. And now we can solve this. 5 times x, 5x. 4 times 12. So I have 5x is equal to 48. Divide out the 5. And my x is equal to 9.6. Let's try the next one. All right, now this one's got some special stuff going on because right now you've got 2 dashes here and 2 dashes there. So that means copy the 16 over. Now I have everything I need. All right, so this time let's say we go 21 to 16 or 16 to 21. Either way, get the same answer. And then I have, since I went with the little part, since I have a part on top, I need a part on top for the second one. Sorry, hit the wrong button. So 2x plus 6 on top over 16. And now let's solve this. All right, we're going to cross multiply. So 21 times 2x plus 6 is equal to, we go the other direction, 16 times 16. Again, we'll distribute that 21. So 42x plus 21 times 6 is 126 is equal to 256. Let's keep going, minus the 126 to both sides. And 42x is equal to 130. Divide the 42. And we'll round this off to about 1 decimal place. So about 3.1. All right. Now let's check out some word problems. This is where knowing those ways to write those ratios are going to come in, because for a word problem, we're really looking for the word to, if possible. But again, we've got those 3 versions that we can find. All right, so we've got a 5-foot tall student casts a 3-foot shadow. So imagine you have the student and he is 5 feet. And he casts a shadow that is 3 feet. So imagine the triangle there. And now let's say we've got, if the tree next to her casts a 45-foot shadow. So there's my tree, and that's supposed to be 45. Oops, sorry, the shadow is 45. We're looking for the height of the tree, so there is my shadow of 45. And again, there's my triangle, so very much like one of those problems we did earlier. So 5 and x is equal to 3 with 45. Now we can solve this out. So 3 times x, 3x is equal to 45 times 5, 225. We can divide out that 3. And my x is 75. And this was the height of the tree, 75 feet. So it's all about knowing how to read those word problems, because you may have to draw out your own pictures to fit the situation for the ratio. All right, let's check out our next chapter, chapter 8. Again, this had all of our right triangle formulas. So with our formulas, again, I'm just going to review these. For a right triangle that has the line in the middle, that is your altitude. So remember, there is your right angle there for this triangle. All right, we've got the short leg is connected to the side. which is the visually shorter leg there of the triangle. The long leg is the longer side of the triangle. Our hypotenuse is the whole entire thing. And one way you can find the hypotenuse, depending on what they give you, add up those two parts of that hypotenuse. So remember, the short side and the short leg and the short part are on the same side of the triangle. Same with the long leg and long part, they're on the same side. So each of these has their own formulas to it for altitude, short part, and long part. And remember, you find those two values and possibly add them and multiply them together and then square root. So don't forget the square root. You also had Pythagorean theorem for your A, B, and C. And again, find that 90-degree angle, because across from that is always the hypotenuse. A and B can be either one, but you do have three formulas here to find your different piece of the triangle. We also had your special right triangles. Now, with your special right triangles, you have the 45, 45, 90 right triangle. So your legs will always make the 90 degrees. And across from that is always the hypotenuse. And you have your two formulas to use when solving for your missing pieces. Then we get into your 30, 60, 90s. So again, find that 90 degree first, because across from that is the hypotenuse. Find your 30, because across from the 30 is the short leg. And then find your 60. Across from the 60 is the long leg. And so it just depends on which of these formulas do you use, depends on what you need. But remember, you have to have the short leg first. So if you don't have that, you need to find it first before you can use your formulas, because all four of these formulas use that short leg in it. All right, some of our last ones that we looked at was the trigonometry. Like before, find that 90 degrees first and locate the hypotenuse. So that way it makes labeling the other two angles that much easier. All right, so wherever the angle is at, across from that is always the opposite side, meaning whatever is left for your adjacent. And we had two groups of our angles here. We had one that was to find sides, two sets of formulas. And then our other one was to find angles, which were the inverses. Notice the little negative ones. So these were, again, just different ratios, and we're looking for different pieces that we need. Okay, guys, I hope you enjoyed remembering a little bit, reviewing a little bit of these last two chapters. Please don't hesitate to reach out if you have any questions.